Node.js allows you to write web applications or any other type of application using JavaScript. In this video, we're going to take a look at what Node is and why you might want to use it. Throughout the rest of the chapter, we'll get you up and running with Node and even build your own Node application. So, what is Node? Node describes itself as Evented I/O for V8 JavaScript. In short, you can write your programs in JavaScript on the desktop, just like you can write programs in your web browser in JavaScript. So let's break down this statement. I/O means input-output, which are the parts of your application that communicate with the rest of the computer or the rest of the world. Things like keyboard input, writing to the screen, and network communication are all considered I/O. Now V8 is a JavaScript engine which interprets and runs your code, and it's what Node runs on top of. Node is a library or an environment that allows you to write your applications in an event-driven way. So what does event-driven mean? If you've worked with JavaScript in the browser, you've used events. They are the main way that you organize your code. You write your code so it says if someone clicks an element, you can run some code. Or if a certain amount of time elapses, you run some other code, and so on. The browser reads through the source code just once, which is where you set up all of your event listeners. Then the browser handles the hard part of actually listening for the events in the actual browser, then simply calls the correct pieces of your code when needed. Node does the same thing. Whenever you call a function that performs I/O, like downloading a file or running a local executable, the process will take some time to complete. But the slowdown is not in JavaScript, but the speed of the network, or the speed of the file system, or the remote service. The JavaScript interpreter isn't busy during that time, it's just waiting. It could be doing other things while waiting for that I/O operation to complete, and that's exactly what Node does. Anytime you make a call that would normally require the interpreter to wait, instead of simply returning the results synchronously, it makes the call asynchronously, and requires you to create an event handler to handle those results. That way, it can get on to executing the rest of your code that doesn't rely on that operation while it waits for that I/O operation to complete. So let's take a look at an example. Here, this code shows two different ways of getting the statistics of a file. Here we have a more traditional synchronous approach, and down here an asynchronous approach. So let's look at how both of these different ways would work. In the synchronous version, we simply call the function with the file name that we want to get the stats of, and it returns the stats object. The interpreter will wait on this line, line 5, until this operation has completed. Now, normally getting the statistics of a file shouldn't be a very long operation, but you can imagine maybe there's something that slows it down and it takes a little while to get the information back. That means JavaScript can't continue on to line 6 until that operation completes. So we can say filename.txt is size of, and then use the size of the stats. But then we go on to some other code here that doesn't actually have anything to do with stats. So if that call took a few seconds to complete, we're delaying this piece of code because it's waiting for that, but it doesn't need it. So why don't we just execute hello world immediately after getting the stats? That's where the asynchronous version comes in. You'll notice we're not getting a return value from our stat call here. Instead, we're passing it a function which will be executed when that stat call is completed. Now, as soon as we call fs.stat and pass it our file name and our callback function, the rest of the code beneath it, here starting on line 13, immediately executes. So since our hello world code doesn't need the stats information, we can put it outside of our callback function and it'll be called immediately. Meanwhile, this function is held in the queue waiting for the information to come back to JavaScript. When it does, this function gets passed an error object, which gives us information as to whether or not an error happened, as well as that stats object that would have been returned in the synchronous version. So now we can use that stats object inside of our function to print out the file name.txt is the size of stats.size. Now, this requires a bit of a change in thinking when compared to other environments like PHP, C, Java, or others. Instead of your program being written in a way that the result from line 10 can be used on line 11, you have to utilize these callback functions for any long-running processes. Now, this paradigm shift can make Node or any other event-driven environment look complicated to begin with, but once you understand the patterns, it becomes much easier. Event-driven programming is a great way to efficiently handle a large number of concurrent operations without having to worry about threads or other complex techniques. So what Node offers us is a full library of asynchronous functions that allow us to write our code in this evented manner. Because evented programming allows us to handle a lot of concurrent operations efficiently, it's particularly well suited for servers that need to handle a large number of concurrent connections, like web servers, proxies, and communication servers. And now we should understand what Node is and why we would want to use it. In the next video, we'll get Node installed and begin writing our first Node application.